Data ay ba't yung iba hindi pa nag-a-appear sa sa ating Google Classroom. Sino pang hindi nakakapasok dito? Rubilin. Sabihin mo nga kung sino yung hindi pa, no? 46 kayo. Ilan ba rito? 42. Meron pa isa. Sino pa hindi nakaka-aid sa Pakipasok na. 42. 42 pa lang kayo eh. Sino pang wala dito sa ating classroom? Sino pa yung limang iyon ang hindi nakakaano? Kasi 47 kayo. Pakipasok na kayo. So narito ay yun, may dalawang nag-add. Meron pang sino pa yung tatlong wala. Tatlo na lang. Sino pa hindi nakakapasok? Mamaya, madidisi na naman kayo. Katwiran nyo, wala na naman kayong 44. Meron pang 4. Sino yung 4 na hindi pa nakakapasok? Pakiin na sa ating Google Classroom. Makikiin kung sino mo narito na wala pa sa Google Classroom, kindly pakiin na. Makikiin. Okay na? So makiki-open muna ng cam for your attendance kuno. Paki-open. Can you please open your cam? Mamaya-maya, mawawala na naman kayo isa-isa. Diba, Cortez? Diba, gawain mo yung Cortez, nawawala ka. Diba?
Hindi po, sir.
Magte-turn in lang. Bahala naman kasi hindi naman kasama sa grading system attendance. Basta magpakita lang ako and then mawawala na ako. Bahala kayo sa sarili nyo. Sino pa paki-open? Carola. Tayag. Carion. Ina. Yung iba ayaw. Sige, bahala kayo. Tingin sa camera. 1, 2, 3. Peace be with you. Talaga naman nakasisakay, naka-peace pa eh. Peace. Peace daw, peace. Tingnan nga natin kung naka-peace ka. Tingnan nga. Ayan. Kamusta ang hapon? Naulan ba dyan? Ang init sa school eh. Mainit. Dinig ba ako? Meron ako audio?
Meron po, meron.
Meron. Okay naman. And, so, saan na ba tayo? Where is that? Where is the love? Tararararan. Tarararan. Okay, meron na.
Meron po.
Yan, ano. So, first and foremost, so, tingnan muna natin kung ano ba yung specific definition ng inyong kurso, which is the HDL. Ano ba yung HDL? Hardware Description Language. So, when we talk of, dealing na with so-called the hardware. So, kaya gagamit tayo ng mga low-level type of language, no? Kasi particularly it's more on parang machine ano to kailangan all of to this just kayo mismo yung gagawa ng paraan para maintindihan ng machine kung ano yung paggagawa nyo sa kanya. So definitely but commonly very very useful when it comes to the designing. Ano i-design natin? Commonly it's more on the digital electronics. Ilan ba electronics nyo? Isa lang ba electronics nyo, right? Tama, Benitez? Isa lang?
Opo, sir. Isa lang.
But anyway, ano na yun? General electronics na yun, ano? I don't know kung umabot kayo sa mga op-amp. Umabot kayo sa mga operational amplifier? Hindi. Cortez. Ano mga naalala nyong mga topic during your electronics days? Cortez?
Sir.
Ano yung mga naalala nyo? Wala kayo naalala? Di ba tapos na electronics nyo? Hindi pa.
Ayun pong SEM, sir. Tambak
Ngayon
po.
din? Naku, dapat pala ito ay second sem. Kasi alam nyo bakit? Kasabay din dito yung logic design. Tama? Tama ba?
Opo, sir.
So, but anyway, ano na lang natin, ano? Kasi the second part so-called all of this just review of what a logic gates, no? I-reviewin natin yung second lecture. But before we proceed to that, so allow me to share ano ba yung mga prescribed definition of what HDL is all about, ano? So, titingnan natin. Yan, ano? So, unahin natin. Ito yung ating subject. But, ano ba to? Can you please read? Sino bang pwedeng magbasa dyan? Karyon? Are still, nandiyan ka, Karyon? Wala kang mic.
Dito po, sir.
Sige, kindly, please read the first slide.
HDL is a language that describes the hardware of a digital systems in a textual form. It resembles a programming language, but it is specifically oriented to describing hardware structures and behaviors. The main difference with traditional programming language is HDL's representation of extensive parallel operations, whereas traditional ones represents mostly serial operations. The most common use of HDL is to provide an alternative to schematics.
Yan, ano. So this is the a poor definition of what HDL is all about. So, sabi natin, since a language, dinidescribe niya yung hardware of a digital. Kaya nga, pag sinabing digital, we're referring to a logic, no? Pag sinabing logic, kasi ang logic kasi it needs only two possible input, ano? And then probably the output is just the same, no? Kung digital yung input mo, probably the output must be also in a digital form. But ano yung digital form? So in the form of what? Either 0 or 1, no? So yan, ano? But with that, no, ikino-convert, kaya nga meron tayo dito yung describing hardware structure and behavior through a so-called schematic diagram, no? Kaya ang gagawin natin dito, mag-interpret tayo ng diagram. So what must be the corresponding inputs, no? And then what is now the output? But anong klaseng schematic? Commonly, it's more on a digital electronics, no? Ano yung digital electronics? Composed of what? Oh, ito na yung mga logic gates, no? Kaya mamaya-maya makikita nyo, ay, ito yon. Kasi when it comes to schematic diagram, we're after, no, a total package para mag-usap. Kaya pag nag-usap na interface mo yan, that's so-called a hardware response yan. Magdi-design tayo dito. Ano tag natin dito? Magdi-debug tayo dito. O, kaya nga nung last meeting natin, di ba? Nagdebug, pinakita ko paano ini-interpret, no, ng command prompt, no, nung by using, kasi pag sinabi command prompt, it's a machine language yun. Lalong-lalo na kinokol niya yung attention na tinatawag nating microprocessor. But ano ba yung composition ng microprocessor? It's so-called a digital circuits, no? Sa digital circuits na yan, alam to this just what? What particular corresponding schematic diagram para siya ay mag-output ng ganito. For example, halimbawang, wag na tayo muna lumayo, no? A simple half adder, no? Pag sinabing half adder, we're referring a two possible digits output, ano? Halimbawang 2 plus 2. Definitely may execution na nangyayari. So what must be the corresponding schematic diagram to represent the output of 2 plus 2? Di magkakaroon tayo ng adder, no? Adder circuit. But what particular? Kasi may dalawang klase, may half adder, may full adder. But depending upon on ilang decimal numbers ang kaya niyang i-produce as an output, no? Kung 2 plus 2, 2 plus 2, ano yung corresponding, kasi when it comes to 2 base 10, no? That's a decimal. 2 plus 2 with the base of 10 is equal to 4 with the base of 10. So, yan ang lingwahe ng user kasi yan ang i-encode doon sa yan ang i-encode natin doon sa keyboard as a client, as a user. But, well, yung ating diagram, I am referring to digital schematic diagram. I am referring to the half adder, no? So, what must be the output? Yan. 2 plus 2 must be equal to what? D is equal to 4. What is now the output? Di ano yan? Kung let's say 0, 1, 0, 0. That's probably the output if you are referring to a 4 digits, no? Or that's correct, the 4 placement when it comes to a digital output, no? But probably what must be the input? The input must be what? Ang gagawin niya it's yung 2 and then the operation is the sum. And then ayun siya. So therefore 1, 0 plus 1, 0 will give you now 0 plus 0 is equal to 0. And then 1 plus 0 is equal to 0. And then you have to carry. Meron ding circuit yung carry. The sum and the carry. So therefore, kung ang sum mo ay ganito, and then what must be the carry? Ia-output na yung sum, ia-output yung carry, and then what must be the final output when it comes to 2 plus 2? It probably is equal to 4, no? Siya. So ano yung lingwahe? Lingwahe niya, ni-interpret niya kasi I am referring to the design of a digital circuit. Enable to kasi sa sobrang laki or sa sobrang dami ng mga what particular language, no, to be exact, ang makakatulong to describe what particular output ang kailangan natin. Kasi at the end of the semester, ang gagawin nyo lang naman dito is maghahanap kayo ng mga outputs, no? All of this, just look into a schematic diagram that represent ito yung input mo, what probably anong magiging output mo. Ayan. So, in an HDL or the hardware description language. But sabi ko nga, ang daming klase, no? Basta makakapag-output ng ganito, and then dumaan sa tinatawag nating digital circuit, and then probably, well, it describes a so-called hardware description language. It's something to do with interfacing. Well, sabi nga natin, the most common use of HDL, alternative to schematic diagram. Bakit? Kasi dito pa lang, alam na natin kung alin portion ng mali. Take note, there are, what are those, are you familiar so-called the binary arithmetic? Na pagdaanan nyo na yan during junior high school or senior high school or introduction to computing. Di ba? Ano yung mga basic operation when it comes to binary operation, binary arithmetic? Ano nga yon? Di ba? Meron tayong addition, subtraction, division, and then multiplication. Tama? Tama ba? Tama?
Opo, sir.
Yes, sir.
Therefore, sa summation, so pag nakakita ka ng 0, 1 plus, actually, pag nakakita ka ng 1, the output ko is equal to 1. For instance, i-type ko na nga, para addition, So in addition, so 1, 0, plus 0, 0 plus 0 is equal to what?
0, sir.
Is equal now to 0. That's correct, no? And then, therefore, anong operation when it comes to the logic or operation? Kasi naka-plus. And then, 0 or 1. 0 or 1, what must be the output? Probably 1. Ayan, And then 1 or 0, what must be the output?
1 pa rin po.
1. So, naka-or. 1 plus 1 is equal to what?
0 po.
1 plus 1 is equal to?
1, 0.
Is equal to 0.
1.
You have to carry the 1. Ayan, Tama, Diba? Or operation yan. 1 plus 1 is equal to 0 is, you have to carry the 1. Ayan na, addition. Kasi gagamitin natin pag-interpret natin ng schematic diagram. So, anong klaseng operation when it comes to the addition? Naka-or. I am referring to 2. Ilang possible ang output niyan? Ang output niyan is so-called 4. 1, 2, 3, 4, no? There are 4 possible, no? Possible output or outcome. Or rather, isa lang yung output but there is 4 combination. May 4 tayong combinations. Ano yung combination na yan? 0 or 0 is equal to 0. 0 or 1 is equal to 1. 1 or 0 is equal to 1. 1 or 1 is equal to 0. You have to carry the 1. Yan siya. Therefore, may 4 tayong combination. 4 yan. Probably, what must be the output? Well, depende kung, let's say, kung gagamitin natin talaga sa operation. But probably, there should always be, if and only if, no? Depending upon kung ano on the usage. But probably, there's only 1 output, no? No matter what. And kung yan ay, ilang combination yan? 4. Kung, ano ba yung pagkakasunod? 1, 2, 4. Di ang sunod ay 8. May 8 combination. Tama? Tama ba? 1, 2, 4. So, anong anuhin natin yan? Kasi ang papatak dyan it's 0. Ano natin 1, 2, 3, 4. 0, 0. 0, 1, 1, 0, and 1, and then 1. So, probably, yan, meron tayong 4 combinations. So, meron tayong 1, 2. Meron tayong dalawang significant digit. Paano ko naman kung I am referring to the variables, definitely meron tayong dalawang variable. The 0, di ba? 0, 1, 0, 1. 0, 0, 1, 1. If it is 3 variables, we're referring to what? 1, 2, 4, meron tayong, so we have 1, 2, 3. 1, 2, then 1, 1, 0. And then 0, 1, 1. And then 1, 0, 0. And then 1, 0, 1. And 1, 1, 0. And 1, 1, 1. So, if it is the case, ito naman. So, meron tayong, from this point, so meron tayong 3 variables, 3 possible, ano? So, ilan naman ang combination na magagawa natin dyan? So, 1, 2, 3, 4, 5, 6, 7. At kulang ng isa. 1, 1, 0, 1, 0, 0, 1. And then 0, 0, 1, 1, 0. Kulang na 0, 0, 1, 2, 3. So probably there are 8 combinations, no? Now, from this combination, assuming na we have to add the 3-digit or numerical, for instance, 1, 0, 1, 0, 0 plus 1, 0. Yan. So probably what must be the final output of this one? 1, 0, 0 or 1, 0. So what is the equivalent? What is the equivalent output? Therefore,
1, 1, 0.
1, 1, 0. Ayan siya, no? 1, 1, 0. How about if it is 1, 1, 1 plus 1, 1, 1. Ayan, ano? So, ngayon, dun sa circuit, no? Sa circuit kasi, since ang operation natin is adder, ang gagawin niyan, what is the sum? Halimbawa, 1 plus 1 is equal to, what is the sum? It's equal now to 0. And then what is now the carry? Carry is equal now to 1. Ayan, no, yung first combination ng 1 plus 1. Ayan, ano? So may carry na. So therefore, ang lalabas niyan is parang nasa taas na yung ano. Therefore, the second significant bit. I am referring to the least significant bit and then the most significant bit, no? Kasi pares naman silang 1, pares naman silang 1 yung dulo, kaya malilito kung alin dyan. But anyway, bandang kanan, the least significant digit, and then yung kabila is the most significant. Ayan siya. Now, second, meron na tayong carry doon sa taas, kaya ang gagawin ng isa, anong gagawin ng operation? 1 plus 1, what is the sum? Hindi pa sum, ano? Meron pa kasing isang 1 doon sa ilalim. 1 plus 1 is equal to 0. You have to carry the 1. Plus 1, what is the sum? The sum is equal now to 1. Ayan siya. And then what is now the carry? The carry is equal now to 1. Ayan siya. So therefore, the first significant digit, then followed by second significant digit, ang sum ng kaunong una ay 0, ang carry ay 1. Yung pangalawa, ang sum ay 1, ang carry naman ay 1. Yan. And then the last, therefore, 1 plus 1, what is now 1 plus 1, since mayroon pang 1 sa ilalim, 1 plus 1 is equal now to 0. You have to carry the 1. And 1 plus 1, yun na naman ang lalabas, no? Ito naman ang pupunta doon sa ating circuit. is 1. And then, ano naman ang ano? And then, carry is 1. Ayan. And then, therefore, all of this just, what is now, meron pa isang circuit, and then all of this just bring down 1, and then what is now the sum? And then the carry is equal now to, wala naman siyang carry. So, therefore. Now, what is now the final output of your half adder? What is now the final output? So, the final output will become what? What is the summation of this one? The 0, 1, ayun 0, 1, 1, and 1. So, therefore, ano yan? Ano uli? 0, therefore, 1, 1, 1, 1, and then 0. So, probably, this is now the output of your half adder, no? Or your adder circuit. Na i-interpret naman ng HDL. Commonly ang HDL, in-interpret niya yung tinatawag nating output. I-convert into a useful waveform. Yan, ano? Anong waveform? So, probably 1, 1, and then 0. So, naka-logic high, naka-logic high, naka-logic high, and then naka-logic low. Yan ang magiging output when it comes to dealing now with so-called adder circuit. If you are going to what? To add this binary numbers 1 plus 1, rather 1, 1, 1 plus 1, 1, 1, probably the answer is 0, 1, 1, and then 0. Di ba? Ano ba ang decimal equivalent ng 1, 1, 1? Di ba 7? Tama? Tama ba? Oy.
Opo, sir.
7 plus 7 is equal to?
14.
14. Kailangan yung output nito, yan, is equal to 14. So, ano equivalent niyan? Kasi yung 0, nire-represent ng 1. Yung 1, nire-represent ng 2. Yung another 1, nire-represent ng 4. Yung another 1, nire-represent ng 8. So, therefore, i-add mo lang kung alin ang may 1. Alin ang may 1? Yung 8, 4, at saka 2. 8 plus 4 is 12 plus 2 is equal to 14. Ayun siya. That's so-called other circuit. Because i-interpret niya yung circuit eh. Anong klaseng circuit? So-called digital circuit. No? Digital electronic circuit. Now, sino nagpapagana dyan? So-called the logic. No? That's a logic gates. No? Ano uli yung mga logic gates? No? Ano uli yung mga logic gates? Baka mamaya, gagawin ko na lang advanced assignment yan. Ano? And then, para i-turn in nyo. Para at least makapag-review or makita nyo, ito pala sinasabi na kaya pala we are looking only for the two possible pangalan nito, equivalent, either 0 or 1. And then what must be the possible output? Probably it's just a logic high or just a logic low, no? Or 0 volt or positive 5 volts. Ganyan lang naman yan. No? Ayan, ano? So I am referring to the circuit kasi based from the definition, the commonly use of this language is to interpret the digital schematic diagram. At para ma-realize natin, kasi pag napapunta kayo sa tinatawag natin semiconductor, lalong-lalo sa mga fabrication ng IC, yan, pagdating nyo, saan ginagamit? Ginagamit pala ito for testing. Kaya pala ayaw palang mali pala yung output. Hindi nung kinuri mo, ito yung theory by using your own theoretical approach, ito yung truth table output. Nung pangalan nito, pinadaan mo sa tinatawag nating interfacing, iba na yung output. Alin kaya may mali doon? All of this just what? Collaborate which one is the exact output pertaining to a so-called digital circuit or diagram. Ayan, ano? But since, sabi nga natin dito, represents as a parallel. Kasi pag sinabing parallel, automatic merong, hindi lang one at a time. Pag sinabi kasing parallel, 8 bits at a time. Or kung ang microprocessor kasi nung araw ay 4 bits, 8 bits, 16 bit, no? Meron 32 bits. Ngayon, it depends on the microprocessor kung what particular series of transition of bits, no? If it is a 4 bits, it is a 8 bits, well, depending upon kung ilan ang orientation. But since the difference, well, it is more on a series, rather a parallel, no? That's a parallel. Next, no? Naintindihan ba? Bakit? Kasi, pag nagano tayo, mamaya-maya, kasi may mga circuit dyan, so all of to do is just what? Yung pala sinasabi ni Sir. No? But since, unahin muna natin, ano ba lingwahe natin? Lingwahe natin so-called hardware description. Pag sinabing hardware, we are referring to, well, interfacing, no? Commonly, hindi gagana yan if there is no such thing as schematic diagram. No? Pag kukonektahin natin. Then, what particular ang ano natin? Well, we are referring to so-called logic gates. Sabi ko nga, nabanggit ko na ata dati yan. Actually, we have 3 basic gates. We have 2 universal gate. And then, we have 2 exclusive gates, no? Na pag-aaralan natin. Kailangan maging familiar tayo doon kasi lahat tayo ay wave output waveform orientation or output waveform interpretation. I-interpret nyo yung output. Ito pala yung output according to its schematic diagram. But the thing is, yan ang magiging challenge sa inyo at the end of the semester. Kasi I will require you to produce your own output using the HDL as a language to interpret the automatic, the waveform, waveform output of your particular circuit. Hahanap kayo. Next. Hernandez, pakibasa nga.
When a language is used for the above purpose to provide an alternative to schematics, it is referred to as structural description, in which the language describes an interconnection of components. Such as structural description can be used as input to logic simulation, just as a schematic is used. Model for each of the primitive components are required. If an HDL is used, then these models can also be written in HDL, providing a more uniform, portable representation for simulation input.
Ayan, So, all in all, ang gagawin natin para may para natin yon, parang makikita natin kung ang circuit ba ay tama yung output, i-simulate natin using HDL. Now, well, lahat naman kayo, di ba, ano ba yung schematic diagram? Any idea? Baka mamaya salita ako ng salita ng schematic, hindi alam yon. What is a schematic, schematic diagram? Anyone? Agregado? Ano ba pagkakaintindi mo schematic diagram? Yes. So, kasi alternative daw to schematic diagram. Meaning, pagka inilagay mo yung, kasi yung schematic diagram, i-convert mo into a structural or textual design by using the HDL language, no? Ngayon, yung schematic na yan, i-convert mo ngayon siya. Para ma-interpret niya, ito yung output. So, when it comes to schematic diagram, it is a representation of each, no? Of each interconnected components, no? kung yan ay lagi na akong half adder. Kung yan ay half adder, ilang gates ang kailangan mo at anong gates ang required para makabuo ka ng tinatawag nating half adder circuit. Naintindihan? Half adder circuit. For sure may mga internet naman kayo diyan. O i-search nyo nga equivalent schematic diagram ng half adder. Paki-search mo nga diyan. And then paki-interpret ilang gates ang nandiyan. At ilang input, definitely ilan ang output. Definitely ang output niyan dalawa. Isang sum at saka isang carry. And then, ilang inputs yan? Well, it depends upon. But the thing is, ilang gates ang laman yan at anong gates ang ini-interpret niyan to come up or to say that it is an half adder circuit when it comes to a digital schematic diagram. Paki-search nyo nga dyan kasi ang hirap pa tanggal-tanggal ng no? Patanggal-tanggal ng screen. Ilan? Anong gates ang nandyan? Ano yan? AND gate, OR gate, XOR gate, may NOT gate? Please try to search a schematic diagram of half adder. Na ano nyo na? Nakita na, Almendras? Ano itsura? Kerubin. Ano itsura?
Ano po, sir? Yung parang araw siya, sir, na parang resistor diode, sir.
Anong, parang
Or
diode?
gate yata, sir. Or gate ang gamit.
Or
Or gate.
ano yung, ilang input meron dyan?
Dalawa po yata kada gates.
Ilan ang output?
Isa. Kada isang gate. Ayun yata yung nakalagay dito, sir. Wait lang.
So we have merong dalawang
Dalawang input.
gates, no? And
Dalawang
then
gate.
there are two inputs, probably meron tayong dalawang output. Ano yung inputs niyan? Ito yung mga i-add mo, no, incoming binary. Halimbawa, anong combination natin? 0 plus 0. What is now the sum? 0. What is the carry? Probably ang i-output, wala namang carry kaya 0. Naintindihan? Oy.
Let's, sir.
When it comes to half adder, well, kasi ano yan combinational logic circuit kasi yan. Designed for adding binary numbers. Well, depending upon kung ilan yung i-input mo or ilan yung combination. However, if it is an half adder ordinary, so kasi merong dyan I think merong XOR gate yan and then naka-cascade or naka-parallel na merong isang one AND gate, no? Yun yung simplified na yan simplified half adder. Pwede naman tayong maggawa ng sariling half adder circuit. Pero kailangan by using the truth table, The truth table. Teka, hanap nga ako ng para sambang circuit. Ako na magano para yung may ito to. Wait para nasaan na siya? Ito na lang. Ayan, ito. Para share window. Cancel. Share tab. Nasaan na? Share. Ay, bata na share. Builder half other pala. Wait, ha? Na ano ba? Nakukuha nyo? Ah? Oy, third year. Ah, may lumabas na? May lumabas?
Meron na po, sir.
Oh, yan ang simple schematic diagram or schematic logic diagram ng half adder. Meron tayong dalawang input, may dalawa tayong output. Ano yung inputs? I am referring to the binary variable A and then the B. And then probably what is the output? Oh, the sum and then the carry. Naintindihan? Oy. Nakita ba?
Opo.
Oh, yan, ano? Oh, assuming, yung kabila, yung may A, B, sum, carry, ang tawag natin dyan is so-called truth table. Naintindihan? Hey.
Opo, sir.
Oh, yan, truth table. Yung A, B represents as an input. And then, sum and then carry represents as an output. Oh, yan. Ngayon, kunin natin ang combination. If it is 2 input, there is, kasi, ano yan, pag sinabing 2 input, 2 raised to n. Pag sinabing 2 raised to n, binary, ay yung n referring to the input. O, ilan ang input natin? Ilan ang input? Benitez.
Dalawa po.
Therefore, 2 raised to 2. When it comes to 2 raised to 2, ilan yan?
4.
4. Definitely, meron tayong 4 combinations. Eh, paano kaya na A, B, C? Meron na tayong 3 inputs. Ilang combination naman ang mapuproduce mo?
8 po.
That's correct. 8 combination. Paano kung 4?
16.
16. Yan. But, yan, ano? So, no matter what, kung gaano karaming combination, basta lahat masasatisfy. Ibig sabihin, kung ito ay 4, lahat ng combination, kailangan masasatisfy yung condition. Pag may mali diyang output, automatic, hindi na, well, mali na. In short. No? Kung pangalan ito, gagamitin natin sa HDL yan, mali yung output, no, that represents output, definitely ang circuit mo, there's something wrong with your circuit. Yan. Using half adder. Sabi natin, anong operation pagka adder? Therefore, or operation. Sa or operation, kasi ganito, pag nakakita ka ng 1, automatic, kahit gaanong zero yan, nasamahan ng isang 1 o 1,000,000 zero, nakakita ka ng 1, automatic ang output is 1. Hindi na kukumputin yun by default. Yan, or operation. Naintindihan? So ulitin natin, no? First combination. Anong first combination ang gagawin ng circuit? Anong input ng A? Anong input ng A? First combination.
0 po.
Ano yung B?
0 din po.
So therefore, anong operation?
Addition. Pag or.
Addition. So therefore, anong gagawin ng ating circuit? Naku, sino ba naman ito ngayon palang papasok? Nakaka-distract. Anong operation ulit, Benitez?
Addition po.
Addition. Therefore, anong logic operation ang gagamitin?
Or gate po.
Or operation or gate. That's correct, no? So therefore, 0 or 0, what is the sum?
0 po.
And then what is the carry?
0 din po.
Yun, kasi walang carry. Yan ang i-output na waveform. Mamaya makikita nyo, sir, ano ba yung waveform? Mamaya. And, second combination, 0 or 1. What is now the sum? What is the sum?
1 po. 1.
1. What is now the carry?
0 po.
0. That's correct. The third combination, we have 1 or 0. What is the sum?
1 po.
1. What is the carry?
0 din po.
0. Yan ang i-output niya. And then the last combination, 1 or 1. What is the sum?
0 po.
What is the and then what is the output for the carry? It's
1
equivalent
po.
sa 1. Yan ano, the half carry. Ngayon tingnan natin yung ano ha. Tingnan lang natin yung waveform para makita nyo ha. I-search ko yung waveform. Waveform. Where is the waveform para ito. Ito. Waveform. Let's try to the half other firing output. Ayan. Nakita? Nakita yung ano? Nakita ang output? Ito yung, unahin muna natin yung AB. Kita na ba?
Kita na po.
Carry the sum half other with 5 input. 0. Hindi, ano muna natin kasi may mga delay pa. Baka lalo hindi nyo maintindihan to. Teka, hanap tayo ng maganda-gandang output that represents, half other output. Nasaan na? Waveform. Waveform. Zero. Wait lang naghahanap ako ng para maintindihan nyo yung waveform. A0. Maintindihan. Waveform output. Ito. 1, 1, 0, 1. Anyway. Sandali lang naghanap ako ng para madali nyo maintindihan yung waveform ng output. 3-bit kasi 3-bit full adder. 2-bit. 2-bit. Wala sila. Ito na lang. Natin kung A, B, 0. Walang makitang 2-bit. Sandali lang mga hanap tayo para at least maintindihan. In the input way of the following will apply to bit other that waveform sa summation of well, tingnan na lang muna natin to para May lumabas na? Meron?
Meron po.
Yan ano? Now yung ano, ganito yung nasa na yung ano? So, we have kasi A1, A2, B1, and then C in. But anyway, so to come up with the waveform, ang mangyayari niyan, ganyan lang, parang triangular waveform ang lalabas, no? If it is your input is 0, and then 0, probably what must be the sum, what must be the carry, no? Kung 0, and then 0, probably 0, and then 0, what must be, assuming na, ano ba to? C in it's zeros, 1, 2, 3, 4. Combination, 0, 0, 0, 0, 1, 1, 1, 1. So, meron tayong 4. So, pinagsama natin to ay kung input mo ay A1 and then the output. So, ito. Kung 0 and then 1, so probably the sum is 1 and then the carry is 0. Ayan, ano? And if it is 1 and then 1, ayan, ano? Probably hindi katapat pala to, no? 1 or 1, so probably the sum is 0, and then all of this you have to carry. But anyway, probably, nakikita niyo yung waveform? Nakikita niyo yung waveform? A.
Opo, sir.
This is an example. Ito, example ito ng waveform. Yan ang i-display. Ngayon, what particular inputs? Ito yung inputs mo. Assuming na A1, A2, kasi ano ba to? The summation daw, and then the output carry C out. Nasa ba? Wala namang ditong C out, ano? And nandiyan lang yung C in relation to the input by constructing the timing diagram. But anyway, kaya nakakaganyan kasi may mga timing circuit, no? Kaya probably, nag-iiba yung itsura ng waveform. But anyway, ito yung example ng waveform. Na at the end of the semester, all of you just look into your own digital circuit and then what particular waveform output, no, ang kailangan mong ma-produce, no, or mag-reflect do sa kanya. But see to it kung isa-isahin natin using truth table. So probably for the first combination up to the last combination, ito yung kanyang magiging waveform. Ayan siya. Now, and with ano nga natin, sample, wait lang sample waveform using sample waveform using where is that? Ito na lang. Yan. And tab. Nakita? Yung yung gumagalaw ng cursor, ito yung mga sample waveform na pag inilagay mo sa HDL programming language or sa ating debugger or sa ating simulator, no? what must be the output? O, ang titignan lang naman natin itong mga output na to. Ayan, ano? Ayan siya, output. Ito. O, yan ang output. Kung itong task na to yung input, o probably ano yung pinaka-output dito? Ito lang. No? Or, using that, ito, no? Ayan, ano? What must be the output? Ayan siya. Ito yung output. And tingnan natin maganda-ganda. Iba palakihan to. Nakikita nyo ba? O maliit? Okay lang. A.
Maliit
Oy.
po, sir. Maliit
Pero
po, sir.
nakikita nyo yung parang triangular, ano? Parang naka-square. Hello?
Opo, sir.
Yan yung pinaka-waveform output. Yan ang consideration natin when it comes to the HDL. What must be the particular or describe a waveform display kung gagamit ka ng particular digital circuit. Assuming, ito yung magiging output. Ayan siya magiging output. Ayan, no? Ito yung input. Assuming na ito sa ilalim, ito yung particular output natin. No? Ayan siya. So, may input waveform and then meron tayong output, no? Waveform. Ito siya. Ngayon, saan na ano yan? Di gagamit nga tayo ng mga, let's say, yung mga test bench, no? Just to what? To verify na ito pala yung waveform output ng circuit na ginagawa mo. Example, half adder, no? Pag pinadaan mo and then, ito pala yung magiging output. Ayan, ano? Again, based from the definition, enable to interpret a digital schematic diagram. So all up to this, just what? Use a language to pertain, or to entertain, the visual output when it comes to the waveform display. Ayun siya. Gagamit tayo na HDL. No? Kasi pag minamano-mano natin yan, maraming combinations, no? Kasi nung halimbawang, sabi nga natin, pagka ang input mo ay dalawa, ilang combination? Ilang combination uli? Pagka dalawang input mo? Gorgod? Gorgod, nandiyan ka ba? Wala na, no? Gorgod? Hey, narinig ba ako?
Hello, sir. Rinig po ba?
Sabi
4
ko,
po.
4. Kung tatlo, ilan? 8. Tama, Gorgod? Nawala na si Gorgod.
Opo, sir.
Paano kung 6 na combination? Pag 6, ilan? Ilan ang combination ang gagawin mo doon?
64, sir? 64 ba?
Ilan?
64.
64. Could you imagine, kung mamanu-manuhin mo yan, yung 64 combination, ay nako, kailangan lahat ay masatisfy mo from the first combination up to the 64 combination. Kasi pagka meron lang isang pangalan nito, hindi gumana sa lahat ng 64 combination, mali na yung circuit mo. Dito pa lang sa HDL, ita-translate niya which particular combination, may particular kung alin doon ang mali. O kaya hindi mo na mamanu-manuhin. O dito interpret na by using a so-called debugger natin. By using a so-called simulator or by using a so-called pangalan nito by using ayan ano kung ano yung mga programming ano natin, kung ano equivalent, no? But with that, so ayan siya. O yan ang ano sample waveform na i-interpret, no? I-interpret ng ating test bench or ang ating waveform editor. If it is kung gumamit kayo ng klaseng ganito. Basta ang kailangan makapag-detect kayo, ay sir, ito po yung aming ano operational amplifier using JK flip-flop. Ito po yung input, ito po yung output. Paano mo nalamin na gumana yung flip-flop mo? Ito po kasi yung waveform na trace dun sa aming simulator. If pinasok nyo yan, nagawa kayo ng program and entertain, no? Yun. Make a program that will run the JK flip-flop. The RS flip-flop, no? Yan, ano? Or the half subtractor, the full subtractor, ano? And probably, ito pala yung pinaka-identified waveform niya. Tanong, question. Ayun lang ano natin, ano, ayan, ano, actually, well, kasi pagka maramihang logic gates, ano, hindi na kayang, well, kaya nga kailangan meron tayong pangalan ito, programming or debugger para malaman natin, may ito pala yung prescribed output niya, no? Ay paano kung libong logic gates na yung papaganahin nyo, no? Ay hindi na kaya ng manual yan. So gagawa tayo, paano mo ma-interface yan? Gagamit kayo ng a certain language that interpret what describes ano kung ano yung talagang describe output niya, referring to the waveform output. Next, HDL can be used to represent logic diagrams, no? Boolean expression and other more complex digital circuit. Kaya ito designed for a digital design, no? Or a digital logic circuit. Thus, in the top-down design, a very high-level description of an entire system can be precisely specified using an HDL, ano? This high-level description can be refined and partitioned into lower-level description as part of the design process. Kasi nagmumukhang machine language na. No? What else? HDL as a documentation language, HDL used to represent a document digital system in the forms that can be read by both humans and computer, and it's suitable open exchange language between the designer. So, ibig sabihin both human, ibig sabihin yung technical expert lang, ano, yung nakakaintindi. Kasi hindi man naintindihan yan ng mga ordinary na hindi nag-aaral when it comes to, ayan na, lingwahe nila, hindi nila maintindihan yan. But the language content can be stored and retrieved easily and processed by computer software in efficient manner. There are two applications, the processing, simulation, and then the synthesis. What else? Logic simulation. Simulator interprets that HDL description and produces and readable output such as a timing. Actually, ginagamit yan when it comes to timing representation. Kaya nga meron tayong logic simulation. And not just only for that, no? Detection error, no? And correcting what particular, ayan siya. Kung merong mismatch when it comes to logic representation. Ayan, ano? Simulation. The stimulus to test the functionality of the design is called, yan, yung test bench, no? Kaya, ngayon pa lang, maghanap-hanap na kayo ng pangalan nito, simulator na magpipit sa HDL. Oh, pwede nga, sir, pwede ba kami gumamit ng notepad? Pwede naman, no? Pwede naman. Kasi may ano doon, merong all of this, just click what particular language ang gagamitin nyo, may HDL doon, no? Pwede yan. Then to simulate digital, therefore, sabi nga natin, paano mo malala? Well, ito kasi instead of using a manual input ng, let's say, kung 8 combination yan, iisa-isahin mo. If meron kang a certain language or a programming na just to interpret this 8 combination na ganito yung output, napakadali. Anong gagawin mo? So, hahanap tayo. Kung nahanap mo, kailangan interpret mo into a programming language, textual language, magagawa ka na naman ng mga declaration dyan. Halimbawang halimbawang X and Y, and then probably what must be the output. And then what must be the, anong situation na paggagawa mo doon sa logic circuit. Yan, Ayan ang tawag natin so-called logic simulation. Definitely, individual pa rin ang gagawa ng logic. But probably, input mo lang doon sa simulator natin na magpipit sa kung anong HDL debugging natin, debugger, na tatakbo at magraran at makikita mo yung output waveform. Then, yun siya. I-verify natin what particular output waveform. Next, yan logic simulation. Ito pala, may example pala rito, yan ilang input meron tayo? Dahil sa diagram. Pasyon, ilang input? Meron kang mic, pasyon?
3 po.
Ilang pasyon? Pasyon.
Hindi ko masyado kita, sir. Malabo.
Hindi ba Kita ko ilang inputs meron dyan?
3.
3. Ano yon? Anong variable yon?
X, Y, and Z po.
Ayun, X, Y, and then Z. That's correct. Ngayon, ilan ang output meron dyan, pasyon? Ilang output? Pasyon? Ilang output meron? Ba't nawala na si pasyon? Mangsat, ilang output meron? Mangsat.
Sir, 2.
That's correct. Ano yung output na yon? Mangsat. Anong literal equivalent? Nababasa ba?
Malabo, sir. Di kita.
Meron naman kayong dinownload nyo na ba yung lecture? Kasi nilagay ko na dyan
Medyo malabo din, sir. SC ba yun?
Yun, S or the sum and then the carry. And another additional, kasi ito yung ilalagay nyo ngayon sa program. Maglalagay kayo ng timer depending upon kung anong klaseng delay ang gagamitin yung time. Let's say 5 nanoseconds, 10 nanoseconds. Depende sa inyo kung anong klaseng, kasi diyan nagkakaroon na ngayon ng tinatawag nating timing. Kaya nga may timer tayo. Kasama yan dun sa pag-i-interpret, Ayan, may mga timer tayo when it comes to 10 seconds. What will happen? And probably, X mo ay ilang combination ngayon? 3. 0, 0, 0. Probably, what is the sum? Ayun, meron tayong naka-delay time, Meron nakaangat na agad yung output. Nakalahati. Pero 0, and then yung halos kalate, pero pagbaksak na ng oras, sa tapos ng oras, babalik sa output ay 0. Yung sum, and then yung carry. Naintindihan? And the second combination, x mo ay 0, then y mo ay 0, the same mo ay 0 uli, no? 0 uli. And then the carry is, the sum is 0, and then the carry is 0. Ayan. Then, followed by 0, 0, and then the 1. What is now the sum? The sum mo is, ayan, no, may kalahating, nasa 1 siya, pero may delay. Paano siya nag-1? No? And then, ang carry mo is equivalent to 0. And then 0, and then 0, and then 1, and then, and the sum mo is 1, and then the carry mo is 0. Next, combination. And then 0, 1, 0, and then what must be the output? The sum is 1, and then the carry is 0. The next, no? O, tingnan natin yung last, ano yung pinakadulo? O, ito, pinakadulo nito. O, yan, ano? We have 0, rather 1, 1, and then 1. Oh, 1, 1, 1. What is the sum? 1. What is the carry? It will equivalent to 0. Ayan siya. No? Now, this is just a simple representation of a logic simulation using a so-called this type of logic circuit. No? Ayan, ano, ina-analyze lang natin, ano yung equivalent waveform. If pinagsama natin, involves na yung tinatawag nating timing circuit. Next, types of HDL. We have the Verilog or the VHD or the very high-speed integrated circuit harvesting language, sometimes called as the VH-SIC, the HDL, and the other one is the Verilog. O yan, yung pinakita ko sa inyo last meeting, Verilog, no? Nakapag-interpret tayo, nakapag-output yung pangalan ko using a so-called the Verilog. Ayan siya. Next, Verilog has syntax as described. Oh, yan na, no? Example keyboard. Oh, yan, di ba? Yung lahat ng program nag-start ng module. Pagkatapos ng program, nag-start ng end module. But definitely, lahat sila ay naka-lowercase, no? Pag nilagay mo dyan ay uppercase yan, hindi gagana yung program mo. Magkakaroon ng syntax, no? By using, ayun siya. Any text between two slashes and the end of line is interpreted as a comment. Yan. Para nagpo-program din kayo. But iba nga lang ang interpretation because we're using a so-called logic circuit. Blank spaces, ignore, and names are case sensitive. Pagdating na natin ng mga lingwahe, no? Ayan, case sensitive yan. Kaya nga, pagka ang tinype nyo ay malaki yung M do sa module, syntax error na because case sensitive. Example. Ayan ang example ng ng Verilog module. Module, sample circuit, ABC, represent. Ano yung open and then close? Anong tawag natin dito sa program? Anong tawag natin dyan? Sa loob ng parenthesis, ABC, and then ano yan? Anong tawag natin, Benitez?
Set po.
Hindi.
Ordered pair. Ordered pair ba? Huh?
Hindi. May tawag dyan eh.
Ano? Elements.
Hindi. Actually, yun yung mga input-output. Anong tawag natin dyan?
Yun, po, sir, yung naka-open close parenthesis.
Oo.
Yung mismo po. Hindi ba, yan, sir? Set.
Hindi. Pagka set, iba yon kasi lingwahe ng arithmetic yon. Sa lingwahe natin ng sa programming. Ano yan? Di ba yan, ano ba tawag dyan? Anyone? May tawag kasi dyan eh. Anyone? Who knows? Variable is something to do with that. Pero meron pang iba eh. Parameters, ganun din. Meron pa rin iba.
Sir, parang nagde-declare.
Ano yun? Di ba doon sa programming, nasa dinideclare mo yan eh. No? Ano yan?
Condition, sir.
Aside from condition, may exact term dyan eh.
Array.
Hindi naman, ano yan, ano pa?
Variable, sir.
Hindi yan eh. Dali, ano pa kayo? Pagkano maalala ko? Actually, may ano yan eh, that's a certain condition wherein yung nasa loob na yan ang i-execute mo. What is the term used? I forgot.
Argument, sir?
That's correct, ano? That's correct. Argument yan. I-argue natin yan kasi nandun yan sa loob. Something to do with so-called an argument, no? No? And with that, so gagawa tayo, i-argue natin. So input mo is pertaining to ABC and then the output mo is XY. And the wire, yan, kasi yung wire, ito yan, no? Merong wire dito, yan, no? Ito yung letter E. Yan, isinasama yan sa program. No? Represents as, yun siya, as, ito, E. Di ba lahat naman ng programming nagtatapos sa semicolon? Semicolon ba tawag dito? Tama?
Yes, sir.
Yan. And then, gagawa mo ng paraan. And then, bahala ka nang mag-execute by using a logic simulation. And then, module, sample circuit. And then, ito kasi yung argument na pagbabatayan ng iyong program. ABC raw, ginawa mong input. And then XY ay ginawa mong output, and then gagamitin mo ay so-called the Verilog as a simulation, and then kung titingnan natin yung ating circuit, nasa ng circuit natin, meron daw and, not, and then or, and then meron daw tayong wire, letter E. Ayan, no? Meron tayong AND gate, meron tayong inverter, and then ayan, meron tayong AND. Ito yung gate 1, gate 2, and then gate 3. Ano yung gate 1? Represent as AND. Ano daw yung gate 2? Nire-represent as NOT. Ano daw yung gate 3? Nire-represent as OR. Ayan, kaya meron tayo dito. In short, kung gagawan mo siya ng HDL program, enable to interpret the logic gates, no, pertaining to this example, ayun siya. A module is a building block with a Verilog. It is declared that the key module is always terminated at the keyword end module, meaning the beginning, actually the starting point of a program is so-called the module. The last point of a program is so-called the end module. If you're going to come up with your own by using this one, and then, gagawa ka na ngayon, alin ang pinaka-body mo? Yung construction ng body mo, from the input up to the OR. Ayun siya. And this is just only a representation of this logic or logic circuit. Ayan siya. Module, sample, circuit, and then, ayan, no? And end module. Yan. Sample yan. Next. Verilog, gates delay. Sometimes it's necessary to specify the amount of delay from the input, the output of the gates. In the Verilog, the delay is specified in terms of time unit and symbol by using, ayan na siya, sharp. The association of the time, the physical time using time scale, compiler, directive. Compile directive stays, back notes, and then, yun siya. Time scale, then 1 nanoseconds over 100 picosecond. The first number specifies the unit measurement for time delay. The second number specifies the precision for which the delays are rounded up in case of the 0.01 1 nanosecond. Ayan, ano? Next, example. Module circuit with the delay A, B, C. Ito, may argument na naman tayo ngayon doon. Yan, no? Input A, B, C, output the wire, and then, yun, end has sharp 30, sharp 20, and then, yan, ano, 30 nanosecond, 20 20 nanoseconds and 10 nanoseconds, and then the end of the module. Ayan, no? That's a module when it comes to the Verilog. Now, in order to simulate circuit with the HDL, necessary to apply inputs to the circuit for the simulator to generate an output response. And then, description provided sa stimulus to design is, yan, ano? Kung nag-convert ka na nito into a textual, i-convert mo naman into a test bench, no? Gagawa ka naman ng test bench, no? By initial statement, specified input by the keyword begin and then the end. And then by using, ayun, ano, the pangalan, dollar sign, the finish. Example, ayan, ano? So, yung kulay puti, yan ang kulay puti is using the Verilog na hindi pa natin tinetest bench, ano, with and kung lalagyan natin ng test bench, so ayan na, yung nasa kanan naman, ano? Then circuit ABC, wire XY, circuit with the delay CW, and initial begin A is equal now to let's say B is equal now to 0. The first significant bit is 0. Input mo ay letter B naman, kasi yan ano yan ang syntax ng ano, no? Pagka ang A mo is equal to 0, yung ganyan. B is equal to 0, ganon. C is equal to 0. And then, with the time of 100 nanosecond. However, if the combination, kung input mo naman ay 1, A is equal to 1 B1, then B, and then, yan. Kung tapos na, no? And then 0, and then 1, what must be the output? Yan ang example. That's the example if you're going to convert the Verilog language into a test bench language. Yan, ano? So, gagawa na tayo ng a program step by step, ano? Kung paano natin gagawin yung block for the entire block. Next. And then, ayan na yung output. Ayan ang output. Assuming, no, with delay. So, probably that's the output. Next, the bitwise operator. If it is not, ayan ang gagamitin. Kung and, ganon. Kung or, ayan, no? Ano bang, nandiyan naman yung symbol. Yan ang gagamitin. Kung XOR, ayan siya. Kung XNOR, merong not na kasama. Nasaan ba yung ano, bandang nasa taas, no? Nasa taas siya. And we could use that, no? If we're going to apply it by using a so-called logic gates. Boolean expression, the specified Verilog, no? Example, X, ano yan? A and B or not C. Naintindihan? X is equal to A and B or not C. Example, X, A or B and C or B prime. Prime is the same as a not and D. Ito yung ano ito yung tinatawag natin Boolean expression. Y is equal to B prime C plus B C prime D prime. Or Y is equal to B not and C or B C not and D not. That's so-called the Boolean expression. Assign, example, ayan siya. So, Dito, ito yung input is X, and then probably, ito yung output, rather X, and yung input mo, ito is, ilang input meron dito? 3. A, B, and then C. Anong operation? And B, or not C. Ayan siya. Dito naman, ang output mo ay X. Anong operation gagawin? Ito, A, or B and C, or B not and D. And then, ilan ang input dito? Ito yung ating input X. Ilan, ito yung ating output X. Ilan ang input dito? 4 naman. A, B, C, and then D. And then yung pangatlong example, anong output natin is Y. Ano mga inputs natin dito? O 3 lang. We have the B, C, and then the D. That's the sample of Boolean expression. Don't worry, kasi pagdating natin ng next meeting, we will go now with so-called a logic, no? Doon magko-concentrate tayo sa mga logic gates, no? Yung pala sinasabi ni Sir na Boolean expression. Next, Verilog. Yan na naman example. Output, X, Y, input natin, A, B, C, and then D. Output natin is X, and then output natin is Y. And then X, A, ano yun? Or, open and close parenthesis, B and C, or, open close parenthesis, not B and C. Assign Y. Ano yung kanyang Boolean expression? Y is equal to, open and close parenthesis, not B and C. Or, open and close parenthesis, B and not C and not D. Yan. Inassign na natin into a Verilog language. Now, a question about this one. Question? Tanong. Oy. Question. Don't worry, kasi by next meeting, we will try to deal with so-called logic circuit diagramming. Para maintindihan nyo to. Question. Pagbasa ng pakitandaan yan Maganyang symbol. Pag nanat, ayan siya. Pagka end, ayan. Pagka or, ayan ang symbol. XOR, ayan siya. And then XNOR, ganyan ang symbol. Then Verilog, and then primitive, user-defined primitive. So, tingnan lang natin yan. And then UDP, sige, pagdating natin ng yan, because we're using only one output for this one. Example, yan ang mga sample Verilog orientation. And primitive using the truth table. Naku, may mga min term pa. And then max term. Ngayon lang kayo naglo-logic circuit, tama, third year?
Yes.
Opo, sir.
Kaya hindi nyo maintindihan itong 0, 2, 4, 6, 7. Tama? Tama?
Opo, sir.
Kasi min term yan. What is the equivalent max term of that particular, the value of X? Yan, X natin. Ano yung X natin dyan? Ito yung ating output. Ano ang input natin dyan? Open and close parenthesis ABC. Naintindihan? Ngayon, ilan ang lalabas diyan? Actually, circuit kasi ito gagawa. Ayan mo, pagdating na lang natin ng next meeting, no? Gagawa tayo ng logic circuit. Kasi hindi nyo maintindihan ito 0, 2, 4, 6, 7. Ang counterpart niyan is max term. Kung alin ang nawawala dyan, yun ang ilalagay nyo. 0, kung ano nawawala, di 1, 3, and then 5. 1, 3, 5, yun ang max term equivalent naman ito. But the thing is, that's a truth table. But anyway, primitive module, i-declare natin as ano yan, CTRTP, no? Yan, registered kasi pag registered, inaano natin a sort of parang memory yan. Naka-register sa X, Y, and then say the wire is W, then W, X, Y, Z, and then probably what must be the output. When it comes to a primitive, no? CRTP. Ito yung sample. Basta nire-represent lang ganyan yung magiging orientation. Ganyan yung magiging klase ng program. Ganyan ang i-encode nyo. No? Ayun siya. Magte-textual programming kayo. And Verilog can be described of any or combination of the following modeling: data gate level modeling, data flow modeling, behavioral modeling. But anyway, for the meantime, hindi pa natin maano to because you are not much more familiar with so-called the gate. Pagka na ano natin yan by next meeting, no? But anyway, this is so-called to describe ito yung mga modeling technique, no? Modeling technique. The gate, data flow, and then behavior. Next, well, definition lang ng gate modeling. Other, and, not, nor, X, or, not, and then yung BAP. Ibig sabihin, short for buffer. Kasi pag buffer, kung input mo ay 0, probably ang output mo ay 0. Binabap lang niya. Ayan, primitive gates of 3 state. But anyway, next, when a primitive gates, gate leveling. So, definition lang naman yan. Alin ba mahalaga? Yan, modeling with a vector, output, declares output vector D with the 4D 0 to 3. While 7, when it comes to the sum. Yan, kasi, magdi-design tayo ng circuit. Yan, tingnan natin, bottom line. Sige, basa-basahin na lang yun lang yan. So, kasi by definition, ang mahalaga kasi makapag-declare kayo ng program o gate labeling. Yan, kasi ito yung circuit, paano mo i-convert into a program. Ayun siya. May dalawang klase ng 4-bit half adder. Ayun siya. Yung kabila at saka ito. Kung itong gagamitin mong itong circuit na to, di ko-convert mo ngayon into a Verilog language. Kung ito circuit, i-convert mo ngayon sa Verilog language yan. 4-bit half adder, 4-bit full adder, and then 4-bit, so probably ito yung magiging flow, ito yung magiging data flow. Ayan siya. And then ito yung implementation ng full adder. Meron tayong 3 input, and then meron tayong 2 output. Ano yung output? The sum and then the carry. Ito, lahat i-convert natin. Kasi i-declare natin itong lahat ng mga logic gates na to. Papunta doon sa program nyo. Pagka i-connecta natin into a 4-bit full adder, that's the time. Pag nag-input ka doon, i-execute niya yan. Next, example. Yan ang example program. Ayun siya. Kasi ang input mo ay X and then Y. And then the output mo ay S and then C. And the Z, ayun pa, when it comes to the full adder, when it comes to the half adder, wala naman, ito yung na representation, input, X, Y, and then Z. Balikan natin yung full adder circuit, ayan, input, X, Y, and then Z, and then output, X, and then Z. So, ano yung argument niya? Yun, ito yung magiging argument niya. Ayan ang output mo. Ano yung wire? S, D1, and then D2, S1. Kung halimbawa, ginawa natin tong S1, D1. Yan, And then, kung gagamitin natin, S1, D1, and another wire. Halimbawa, what is the D2, no? 3, no? Kung halimbawa ginawa natin, dineclare natin tong S1, D1, and then D2. S1, D1, and then dineclare natin ito. Yan, 2 lang dito. Dito sa bandang output is 3, kaya magdi-declare tayo ng 3 wire. Wire papunta sa S. Or rather, hindi na, output na pala dito. Ito yung isa. Ito. And ito yung pangalawa, or kung ginawa mong D1, o kung ginawa mo itong D2. O, ito hindi natin i-declare kasi input to. O, ito i-declare natin a connection between this one. And then ito i-declare natin as a wire. Ayan, papunta rito. And then ito i-declare natin itong wire as papunta rito. Pero ito, hindi natin dineclare kasi dineclare na natin ito as an output. Probably, so meron tayong tatlong wire. Isa, dalawa, and then tatlo. So, kung titingnan natin, ito na siya. S1, D1, and then D2. Ano siya? Oh, output for the first XOR and 2 AND gate. So, nasan siya? O, yun, ano? Ito, XOR, ayun ang XOR. Ayan. And then, ito, yung ating first AND gate and then the second AND gate. Ito sabi, first, it's dineclare S1, 2, and then for the input. So, therefore, ito yung AND gate and then another AND gate. Magdideclare tayo ng wire dyan. Magdideclare tayo dito ng wire. And magdideclare tayo in between ng dalawang XOR gate. Ayan siya. S1. Ay, ma'am. Sige po. Uwi ka na. Ayan, no? Naintindihan ba? Third year. Ay. Wala nasagot. Kung walang nasagot, siguradong dalawa lang yan. Either naintindihan or hindi naintindihan. Alin doon?
Medyo blanco pa, sir.
Wala. Hindi ba ako dinig? Kasi ganito nga, kasi kayo ang magdi-declare niyan. Alin ba yung input mo, alin ang output? O paano nakakonekta yan? Kaya nga dito, ito lang muna ha. Yung module for full adder. Nasaan ba yung dito? Tingnan natin nga yung dalawa. Kasi ito yung kanina, dalawa X, Y, S silang. Ngayon, alin dito lang yung may wire na di-declare. Definitely, ito lang yon. At saka ito. Dalawa lang naman yan. And may dalawang output. Tingnan natin. Nasaan siya? X, Y. Dito hindi na dineclare. But anyway, S, X, OR, and C, X, Y. Now, if we're going to use the full adder, ito naman, ito naman yung circuit. Ito yung circuit, ha? Oy, nakikita yung circuit? Ito yan, ha? Tawag natin dyan so-called the full adder circuit. Ngayon, para siya ay gumana sa full adder, i-convert mo ngayon into a programming. Ayan siya. SC, output, XYZ, input. Input, ito yung argument natin, no? Gagawin natin input. Anong input natin dito? XYZ. Ano output? SZ. And then, anong mga wire na ginamit? S1, D1, and then dito. Wala lang nakalagay. Maaring narito yung S1. Ito si D1. Ayan ha, simula rito. Ayan ha, D1. Dito, simula rito hanggang dyan. And then, ito na yung output. Ayan siya. Half adder. So, entertain, half adder, S1, and then half adder 2, and then OR, and then that so-called end module. Yan ang yan ang Verilog programming when it comes to the full adder, no? Ayan siya. Hey, are you with me? Yan ha. But anyway, next meeting, no? Pupunta muna ako sa Maggagawa muna kayo ng mga Boolean expression or Boolean logic diagram. Sasanayin ko muna kayo magawa ng logic diagram kasi sa ngayon, ay nako, mukhang sabi ko nga, kasi syempre, yan agad na example sa next, full adder, or you may use this one as ayan, ganyang program. Magiging output niyan is, ayan siya. And Ito 2 to 4 decoder. Oh, iba na yan, decoder. Oh, yan ang circuit. Ito yung diagram ha. Oh, yan. Ayan mo, next meeting, magsasanay kayo. Babasa kayo niyan. And ito yung truth table. Nasa kabila. Oh, EAB. Ano yung EAB? Input. Oh, ilan ang output meron dito? Sa example sa decoder. Oh, ilang output? Hey, ilang output meron dyan?
4 po.
4. Ano yun? D0, D1, D2, D3. Oh, yan. That's correct. Next. So, ayan ang sample Verilog program using that diagram. Next, 2 to 4 line decoder. Ayan siya. And, ayan circuit. Ayan ang example program. Ayan, ano? Oh, ito yung Verilog ha. Wala pa yung test bench ha. Kasi i-convert nyo pa yun sa test bench. And 3-state gate. Oh, ayan, 3-state gate. Wi-Fi. Well, ano lang natin yan. Module, example, 3-state. Ito yung kanyang program. Ayun, nasa baba. Next. Data flow modeling. Basta, ito lang yung kanyang sequence of programming. It should always be start with the module and then magtatapos sa end module. Lagi na lang meron tayong argument. Data flow, description, sample, data flow modeling, ay an example, behavioral, ay an example. Ito yung diagram, no? Naku. Ayan, ano? Example ng schematic diagram. Ito yung kanyang truth table. Ilang input meron dito? Ilang input? Hey. Ilang input?
Anim, sir.
Ilan?
Anim.
6, that's correct. Ilan ang output?
Isa lang po.
Isa. Pero commonly yung functional table, no, ginamit lang niya yung dalawang input S1 and then S0. Ayan. And then ganyan yung kanyang sample programming, ano? Then behavior modeling 4-in-1, writing. Yan na, ito na test bench. Initial, the block and close. Yan, pagka test bench naman, meron ng begin and then the end. Then the time, it should always be by using the sharp, no? Ayan, and then D prime repeat. Ayan, ano? That's sample. Declare, local, and module. Module, and then declaration na. Ito na pinaka-body. If magra-write tayo into a test bench. Pag sinabing test bench, kukunin natin yung waveform. Pag nagagawa lang tayo ng Verilog, titingnan lang natin kung gumagana yung circuit. Pero kung titingnan natin yung waveform display, gagamit tayo ng test bench, no? I-convert natin. Ayan siya, no? Stimulation module design and then module, example. Ayan, ito yung kanyang mga syntax, no? Display, write, monitor, time. Actually, display and monitor is just parehas, no? Pero yung display, one time lang. Yung monitor, may variation. Kung meron kang dineclare na time, well, time, display, simulation time, finish, terminates the simulation. Ayan ha. Should always be used with the dollar. Example program. Ayan, ano? Stimuli write test bench and then regular, registered TA, TB, TS, wire, Y, and then maximum 2 times 1, and then slice, and then, yan, test bench natin yan. So, example yan, monitor, select, and then BA. Ano ba yung, di-display lang nito yung D, B, and then, ayan siya. Ayan, oh. Ito, oh. Ayan siya. So, what must be if TS is 1, TA 0, TB is 1, probably what must be, ano i-display niya? Oh, i-display niya yung B, i-display niya rather ito A and then B. What must be the output? Ano di-display niya? Ito. Next, data flow. A, output. Ito ha. So, since ito yung sample mukha ng program, kailangan maging familiar kayo dyan. Kasi pagkatapos natin ng familiarization with so-called logic circuit, we will go na with so-called type programming. Ayan, module and then writing a test, output. And then structural, hierarchy, basa-basahin nyo na lang yan. Ang mahalaga kasi, makapag-debug tayo. And two-line decoder, medyo malawak na yan kasi decoding na. Tingnan nyo kasi ang lawak na ng circuit na to. Malaki pala yung nabigay na circuit. Ayan, ang sample program. Ang sample program, ha? Ayan siya, And sample program, multiplex, sample program uli, then other. Ayan ang other. Naku, may K-map pa. Are you familiar so-called the K-map? Hindi, hindi pa. Hey. Yan, siguro include ko na rin yung mga K-mapping. Kasi kasama yan, kine-K-map to. Para, ito ito yan, saan ba? Nakita yung cursor ko? Yan, yung kulay green na yan, yung kulay green na yan, ito lumabas sa circuit. Ayan, ito. Yan, ito yan. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Ito yan, ito yan, ito yan, ito yan. Anong titingnan dito? Titingnan natin, 0, 0, 1. Nasaan yung 0, 0, 1? 0, 0, 1. Ibig sabihin, nasaan siya? 0, 0, 1. And ito ay 1, 0, 0. 1, 1, 0, 0. Ayan. 1, 1, 1. So, 1, 1, 1. Ito yan. And this one, it's counterpart naman yung kabila. Huwag kayong mag-alala. By next meeting, magsisircuit kayo. Maglo-logic diagram tayo. And another full bit for other. Ayan ang sample again. 4 bit. Ayan ang mukha ng program. And 4 bit. And the end module. Sample ng program. And then the last one, we have, ayan siya. Question. Mukhang nakanganga lahat. No? Tanong. Question? A. Ay, tanong. Aba, wala na ata akong kausap. Wala ba akong internet? Dinig. Question. Siguradong by next meeting, ay, yun pala sinasabi ni Sir. No, yun pala. Tanong?
Wala.
Ito naman ang challenge sa inyo. Ngayon pala maghanap-hanap na kayo ng debugger or simulator na gagamitin pang-program ng Verilog. Nagkakaintindihan? Kasi ang concentration natin dito is dealing na with so-called the output. Output ano yon? Output waveform. And next meeting, ay nako, yung pala ang sinasabi ni Sir. Magbabalik tayo sa tinatawag ng review ng ating logic diagram or logic circuit. Review tayo next week. But next I will post kung ano yung gagawin nyo dito. And then all you have to just turn in kung ano yung paggagawa ko. Nagkakaintindihan?
Yes po, sir. Yes.
Question. Ngayon magbasa-basa na kayo about the logic circuit. Oh? Kasi sabay nga yung logic design saka yung HDL. Mukhang lugi kayo. Salita ako ng salita, hindi nyo mo pala maintindihan. Bakit? Kasi wala pa kayo sa point na ganon. Katulad ng mga terminology na min term, max term, K-map, no? And then truth table, no? Halimbawa, naka-anded to, naka-i-or natin dito. So, by next meeting, sige, gagawa ko ng paraan para at least ma-appreciate nyo, yung pala yung logic design. Although, kahit hindi naman tayo logic circuit, kasi part yan kasi ng ng HDL. Ang HDL kasi minamanipulate niya, it's how to read the digital circuit design. No? How to read the digital circuit output. How to read the digital circuit waveform. Ayun siya. Question. Well, kayo ang bahala. Basta nakakapag-output waveform. No matter what, no? Kung kayo gumamit sir, gumamit kami ng ganitong debugger. So be it. Basta ang malaga, tumakbo yung program. Halimbawa, nagawa ka ng dalawa. Sir, meron akong halimbawa, nagpa-assignment ako sa inyo nagpa-activity ako, perform 2 AND gates, no? What must be the output of that 2 AND gates? Having 2 inputs, no? Yun. Ite-test bench nyo ngayon. Pero kailangan may theoretical approach kayo. Kaya nga, by next meeting, tuturuan ko kayo kung paano kayo mag-truth table. Nakakaintindihan? Amiela, kahit anong debugger, kahit anong pangalan nito, compiler ang gamitin nyo, ha? Nakakaintindihan? Basta tatakbo yung ginawa nyong program. No? Kung yan ay multi-sim, bahala kayo. No? But see to it, kayo ang gagawa ngayon ng paraan para tumakbo yan sa unit na gagamitin nyo. Kasi nagdidepende kasi sa unit na gagamitin. Titingnan ko lang naman sa inyo yung waveform, output waveform. Saan gaganin? Meron kang Verilog programming, convert mo ngayon sa test bench. Yun, pag sa test bench, meron tayo tinatawag na waveform editor, doon ko makikita. At doon nyo papakita, ay sir, ito na po yung output na pinagawa nyo 2 AND gate. Na naka-series. Ito po yung output. Ayun siya. Question. Question ng karunungan? Tanong.
Wala po, sir.
Magtanong na. Ngayon pa lang, maghanap-hanap na kayo ng gagawin yung pang-debug. Pang-compile ng program. Baka mamaya, but anyway, kung minsan nagkakaiba ng syntax, pero isang logic, ha? Kaya nga meron tayong logic simulation. Gagamit tayo noon. Kung tama yung diagram na ginamit mo, well, kailangan ganito yung output. Titingnan natin. No? Kaya magre-review tayo on next meeting by using a so-called different types of logic gates. No? Kasi gagawa tayo ng logic diagram. Magiging familiar. Question ba? Tanong. Carry on. Question? Tanong na. Salazar, question? Any more question?
Wala naman po, sir.
Wala.
Yung binigay ko sa inyo is just only an information of what HDL is. And at least, ito yung mukha ng program. Ay, ito pala yung program. Diba? Diba kung sa C++, diba? C in and then C out. Diba? Ganyan yun, diba? Diba? C in, C out. Diba? Tama? Tama? Nakapag C++, nakapag ano ba kayo? Question, Bila Vicencio. Tanong, before we finally end our session for today. And then, siguro by tomorrow, I'll gonna post kung ano yung gagawin nyo for your first activity. Nagkakaintindihan?
Yes, sir.
Likayan, tanong. Magtanong na. Oh, anong challenge ko sa inyo? Ngayon pa lang, no? Sabi ko nga pala, nung first meeting ko pala sinabi, maghanap-hanap na kayo kung ano mga compiler ang gagamitin nyo. No? Naintindihan?
Okay po.
Question, before we finally close our session for today. Wala na?
Wala na po, sir. No more
Wala na
question.
talaga. Likayan, wala na talaga?
Wala naman po, sir.
Oh, siguro hindi kayo nakakasunod kasi hindi kayo familiar sa mga circuit pa. But anyway, pagdating natin next meeting. Kung wala na, and then siguro I'll try to end up this session, and then by next meeting, ipopost ko na naman ulit kung kailan tayo may next meeting. Nagkakaintindihan?
Opo, sir.
Kung wala
Opo,
nang
sir.
tanong, kung wala nang tanong, and then you may now leave the room, and then stay safe, and then see you on next meeting.
Okay po, sir.
You
Salamat.
may now, you may now
Bye.
leave. Okay. You may now leave.
Bye, sir. Salamat po.